Hello everyone, welcome back to Few. In today's video, I'm going to show you how we can monitor our web application like a pro using Prometheus and Grafana. These are some of the most powerful tools in the DevOps world which we can use to track the metrics and visualize data from our application. Now, whether you are running a single web server or a complex system, this setup will be the game changer for monitoring and performance insights. So, in this video, we will set up a Flask web app, configure the Prometheus to scrape the metrics and visualize them beautifully in Grafana dashboard. And the best part? It is going to be all containerized with Docker for easy development process. And this is what we will be covering today. We are going to set up the Prometheus, Grafana and our Flask app. Then we will be configuring the metrics in Prometheus. And lastly, we will be visualizing them in Grafana. And by the end of this video, I assure you that you are going to have a fully functional monitoring setup for your own projects. So let's get into this. Alright, let's start by walking through the files that we will be using. I have got everything ready in this project folder and I'm going to explain you every file briefly. So first up, we are going to have the .env file which will contain the sensitive configuration detail. It is just one detail, which is Prometheus hex code. It is a shared key that will be loaded into our Flask application. So to generate this hex key, what we will be doing is we will be just opening the terminal and here we will be pasting this command, which is openssl rend-x and then 32. This is going to give us this hex key, which we are going to copy, close the terminal and then paste it over here into the .env file. And this is just what we are going to have for this file. So let's now save this file. This is going to keep this sensitive data, Prometheus hex key, out of our main code base for security purposes. Next, we are going to have the app.py file, which is our Flask application. This is going to serve the web pages, track the metrics like endpoint clicks, active requests, database query time, and errors. Here in this file, we will be also using the Prometheus client library, which will help us expose these metrics to Prometheus, which will then scrape them periodically. We will dive deeper into this file after a few minutes after we have talked about all these files, okay? Then next, we are going to have the requirements.txt file. This is what we are going to have into the requirements file. This is going to contain the dependencies that we will be needing to run our Flask application. The requirements are Flask, request Prometheus clients, and python.env to load our environment variables from the .env file. Okay. Next, we are going to have the Docker file. This is going to define how we containerize the Flask application. Now, this Docker compose file is the important step because it is going to orchestrate multiple services including Prometheus, Grafana and Flask App, and each service runs its own container, making our entire stack modular and easy to manage. Okay, we will be writing the code for this Docker compose file afterwards. And in this Prometheus configuration file, we are going to tell the Prometheus where to scrape the metrics from, such as our Flask App and Node exporter, which will collect the system level metrics. Okay. And finally, we have the Grafana file, which is going to be the simple configuration file for Grafana, where we are going to define the admin credentials and server settings. This is going to ensure that Grafana is set up the way we need it right from the very start. Okay, so now that we have all of the files in place, we are ready to start configuring these services. So we will begin with the Docker compose file. So we will be first off starting by declaring the version. Then we are going to have the services, inside which we are going to have our first service, which is Prometheus. This uses the official Prometheus image and binds the Prometheus configuration file to the container. Prometheus is going to run on the port 1990 and it will restart automatically if it crashes. And then the command option which you see over here specifies where the config file is located inside the container. Next up, we are going to have the node exporter. This service is going to collect the system level metrics such as the CPU and memory usage, and it is going to export them on the port 9100. Okay, Prometheus will scrape these metrics along with those from our application, which we will define into app.py file. Then we are going to have the Grafana service, which is going to use the Grafana enterprise image. It is configured to store the data persistently in a volume called Grafana storage so that you don't lose your dashboard even if the containers restart. Finally, then we have the Flask App service, which is going to run our web application. This is going to use the Prometheus hex environment variable from the .env file, exposing it on our application on port 5001. This service is also going to restart automatically if it crashes. And notice this volume section over here. This is going to ensure that the Grafana's data is stored persistently so that we won't lose our dashboards or settings when we restart. So that is what we are going to have for the Docker Compose file. So with this configuration, what you have done is you have brought up the entire stack using a single command. Let's now configure the Prometheus to scrape the right metrics. So first, let's save this file and open the Prometheus file. So as I told you earlier that this Prometheus YAML file, it is going to tell Prometheus where to scrape the metrics from, right? And it also specifies how often to do it. So at the top, we have the global section, which is going to define the default scrape interval for all the jobs. Here we are setting it to 15 seconds, meaning Prometheus will fetch metrics from each target every 15 seconds. You can adjust this based on your application needs, okay? Then we have the scrape config section. This is where we define the targets Prometheus will scrape the metrics from. So the first job is going to be the node exporter. It is going to target the node exporter service, which is running on the port 9100. This is going to give us the system level metrics, okay, which are incredibly useful for monitoring the health of our server. Then the second job is for the Flask App, which has a custom scrape interval of 5 seconds, and we are specifying the metrics path as /metrics. Prometheus here will scrape metrics from our Flask application, which will be running on Flask App 5001. So this is where all the metrics are defined into app.py file, like an endpoint clicks, response time, database query will be exposed, okay? So yes, this is the configuration we will be needing for Prometheus. So now Prometheus is set up to monitor both system metrics and our application specific metrics. All we need to do is start the container and Prometheus will begin scraping the metrics automatically. So let's now save this file. So let's now take a closer look at our Flask application and how it integrates with Prometheus. So over here at the very start, we are starting off by importing the necessary modules. We are importing the Prometheus client library that will help us define and expose the metrics, while .env will load our environment variables from the env file. Then over here we have the shared key for the Prometheus, which will be coming from the env file. And then over here we are going to define the different metrics that we are going to use for this application. So first off, we start by bringing in the counter to count the endpoint clicks. Then we have histogram to track the response time. Then we bring in the user's location using the counter. Then we have another counter to track the errors. Then we have histogram for tracking request sizes. Okay, another histogram for response sizes. Then we track active request. Then we track database query times. And at last we have another counter to track the different user signups. Then down over here, we define the getLocation function, which is a helper function which uses the IP API service to fetch the geographical location of a user based on their IP address. And this data is logged as metric in Prometheus. Next, we have the before request and after request function. The start timer in the before request runs before each request and starts a timer. And then the track metrics runs after each request. It basically logs the endpoint clicks and calculate the response time, which is then recorded into our endpoint latency histogram. Over the next, we have the error handler function, for which we have also added custom error handlers to track the 404, 403 and 500 errors. And over here we have those. These are recorded into the error counter metrics with the endpoint and the status code for better debugging process. And finally, then we have the metrics route. It is where all the metrics are exposed. So when Prometheus scrapes this endpoint, it is going to get all of the metrics that we have defined in a format it can understand. And then down over here, we have different endpoints to track the different metrics for each endpoint. We have for sign up, for error, for contact, about and home page. And finally, at the last, we have the entry point of our application, which will run the application on the port 5001. And we have also enabled the debug mode to see the logs in the console in real time. So now with this setup, our app provides valuable metrics to Prometheus, helping us monitor its performance and health. Okay. Next, we are going to talk about how we can containerize this application using Docker. So in this Docker file, we are going to package our app and its dependency into a portable container. So this is how we are going to start. We start by using the official Python Slim image. This gives us the lightweight base with Python pre-installed, okay, which is perfect for running our Flask app. Next, we are setting up the working directory inside the container to /app, and then we copy all of our files from our project folder into this directory. Then we install the required dependencies by using the pip install with requirements.txt file, and we are using the no cache dir flag, which keeps the images small by skipping the unnecessary cache files. Then we expose port 5001, which is where our Flask application will run. And then finally the command instruction, which specifies the command to start the app, which is python app.py. So this is what we will be having for the Docker file, which is going to build a container image for our Flask application. And now to build this image, all we need to do is to run the command, which is docker compose build. This will package the app and make it ready for deployment. So let's do that right now. Save all of the files that you have till now, okay? Then run the command docker-compose and then build. And then we will hit enter, okay? And you can see it has started building this. So it might take few seconds or few minutes for you. After it is finished, next, we are going to set up Grafana and prepare it to visualize the metrics we are collecting. So close this terminal after you are done building your image. Then open the Grafana file. So this is what we are going to have for our Grafana configuration file. So under the security section, we are defining the admin username as admin and admin password as password, okay? So these credentials will help us log into the Grafana once it is running. You can and should change these for production environments, okay? And for the server section, we are specifying the port Grafana runs on, which we have set to 3000. This is going to match the port mapping in our Docker compose file. Then we have the path section, which specifies where the Grafana stores its data and logs. And here we are using a persistent volume, which ensures that the dashboards and settings won't be lost even if the container restarts. So this is what we will have for this file. Once you are done, save this file. And now we can start our entire stack by running the command docker compose up-d, which will bring up all the services including Prometheus, Node Exporter, Flask App and Grafana. So for it, make sure that your Docker desktop is running. Only then we are going to run the docker compose up-d command, okay? And once your Docker desktop is running, over here you can see that we don't have any containers or images as of now. So let's head back to the VS Code. Open the terminal, and over here let me just clear this. Then we will run the command docker compose up -d, which is going to pull the Grafana, Prometheus and Node Exporter images. Okay, so it is done. Now our containers, Node Exporter, Prometheus, Flask App and Grafana are started. So head back to the Docker desktop, and over here you are going to have these 4 images, and into the containers you are just going to have Grafana web app container, okay, which is going to have these different containers. Perfect. And over here you can see it was last started at 35 seconds. So once everything is running, we can access the Grafana at the localhost 3000. Let me just refresh this. And over here, yes, you can see Grafana is accessible. And then here we have to put the email or the username which we provided into the Grafana configuration file, which was admin, and the password was password. And then we will log into this. And once we are logged in, we have access to our dashboard. And over here, now we have to add Prometheus as a data source so that we can start creating visualization. So for it, open this hamburger menu over here. Then into the data sources, you have to click on add data source. Then over here, we have Prometheus. Click on this. Name it as Prometheus itself, and in the Prometheus server URL you are going to provide it as http prometheus then 9090. Okay, leave the rest to default, head down and click on save and test. You should get this message which says successfully queried the Prometheus API. And now we can start to visualize our data by building a dashboard. So for it, we have to go into the dashboard. Then click on new, then click on new dashboard. We will then click on add visualization. Select the data source as Prometheus. And now in this dashboard, we are going to visualize our Flask App metrics. So these dashboards are a collection of panels, each displaying specific data. So now this is our first panel. If you want to change its title, you can do so from here. And then in the query editor, you can enter a PromQL query to fetch the data from Prometheus. Now, what are the data that you are getting? You can look over here onto the 5000 localhost 5001/metrics, and this is the metrics that you are getting. Okay, and on the localhost 9100, here we have the node exporter metrics, okay, such as the CPU seconds and the discard time seconds, and there are many metrics which you are getting from here. If you want to test your application, you can just go to the localhost 5001. You will have this welcome to the home page. This is your web app, right? You can go to the about page just like this, which says welcome to the about page. You can go to the error page, which says internal server error, and we also had a contact page. Okay, so that does mean our application is working perfectly fine and we are also getting the metrics. But now we want to visualize this data. So into the metrics section over here, you have all of these endpoints from our Flask application, and you also have the node endpoints, node exporter, which we used, like node CPU guest seconds total, discard time seconds. You can just select any of these and create your data over here. So for now, we will be going with endpoint total clicks or endpoint clicks total. Okay, then we are going to have this options section in which we are going to click on customs, and over here we are going to say endpoints. Okay, after this, over here for the last 6 hours, you can say last 5 minutes, and over here you have the data that you can visualize. Over here you have this home page, you have this about page, then over here you have this error and contact page. You can see the labels over here. If you don't want it to be the single line, what you can do is just go to the graph styles and then select the bars. Okay, over here you can provide the gradient mode, whatever the opacity, hue or schema that you want to use. Okay, so this endpoint clicks total metric tracks the total clicks on each endpoint. So as you type, the graph updates to show the data in real time. You can just head over here. You can just access the contact page various times. just enter it again and again, okay? Or go to the error page just like this once again, okay? Head back to the panel and then over here go to the 15 minutes. You can see this changes for the home page, and over here we have the data too. So over here you can see that we have accessed the contact page many times, then we have accessed the error page after it, and then we have the about page which has the lowest metric, and the home page we cannot see over here. So let's just go to the home page now, access this 2-3 times, just do this, okay? Head back, then refresh this. Over here you can see that we have accessed the contact page 6 times, we have accessed the error page 5 times. For the home page we have accessed it only 1 time, and for about page we have also accessed it 1 time. So let's do it for the last 30 minutes, and this is your graph. And now to save this, what you have to do is just click on save dashboard and then provide the dashboard name. We are going to provide it as Grafana Flask App dashboard or something like this. Then click on save and your dashboard is saved. And if you want to change the panel name, because over here we are bringing in the endpoint clicks total, you can just name it whatever you want. And just like this, when you head back to the localhost 3000 and into the dashboards, you are going to have your dashboard over here. And now if you want to add another panel, you can just click on add, then click on visualization. Over here, we will select another metrics. Let's say for now we are selecting with the active request. For the options, we are going with custom, say endpoint, and then do the same thing that you want to do. Provide the panel name as active requests. Then in the graph style, if you want points, click on points, bars or lines, whatever you want to use, okay? And then click on save dashboard. Provide the name that you have over here, active request dashboard, and then click on save. So now when you go into the dashboard, into the Grafana Flask app, you are going to have 2 dashboard. One for the endpoint clicks total and another one for the active request, okay? And just like this, you can create as many panels that you want for your different metrics endpoints, okay? So basically what we did over here is we had a panel which was updating in real time with the data from Prometheus. So metrics like the clicks per endpoint, response time and error rates are all visible. You can check them by trying different metrics that we created into our Flask application. Okay, so now with everything that is working, you have now fully functional monitoring setup for your Flask application. In this, Prometheus collects the metrics and Grafana visualizes them, giving you the insights of your app's performance, which is very essential for any web app or even your websites. You can do the same for your websites too, okay? So yes, that is it for this video. I hope you have learned how to monitor your web app with Prometheus and Grafana, including how we can set up the Docker Compose, configure Prometheus, containerize your Flask application, and then visualizing metrics in Grafana. I hope you got the hold of these concepts by this video. So if you enjoyed this video, please do not forget to like and also subscribe. And if you have any doubts, please drop them into the comment section below, or you can even join our Discord server. The link is in the description box below. And with that, I will see you in the next video. Till then, bye bye and take care.